Good day. This is Group 2 or Deal a Wheel Car Dealership Analytics System Group. I am Benjamin Fernandez and I am here with my partner, Miguel Layosa, and this is our final comprehensive project documentation report. So first, section 1 this is our assigned topic and dataset. We have the Deal a Wheel Car Dealership Analytics where we chose, and our domain focus is a large-scale multi-location automotive retail, inventory logistics, sales price commission structures, and credit underwriting operations across the Philippines. For the first part of our project, we did project feasibility assessment with technical feasibility, having the data scheme transitions logically from an optimized 3NF to OLTP to all up into MySQL. And for our operational feasibility, we were tasked to have 5,000 plus employees and 5,000 records and a lot of branches. And as you can see here, we have 55 regional branches and 5,200 employees. For our economic and business value, we ensure that consolidating multi-branch transaction pipelines eliminates localized reporting latencies, standardizes volatile commission calculations, and all the data accuracy and highlights needed for executive strategic planning. And last, for section 1, you can see the dataset source and generation methodology. So you can see the primary source framework. The core architecture is modeled on structured enterprise vehicle retail frameworks, and the synthesis and fabrication is its realistic data constraints were procedurally expanded using programmatic data fabricators to match your dealership volume, with 5,000 transactions rows mapped to a workforce profile of over 5,000 corporate rows distributed across regional administrative branches. So section 2, our business description. You can see here, Dealer Wheels, a major automotive dealership with different brands, different models that we can use or we sell in our car dealership. And to optimize customer lifetime value, the company's daily operations combine vehicle selection with specialized services, custom consultation, in-house third party, and all those different incentives that comes with the branch. So let's move on with our core business processes. So first, we have these different core business processes, and I leave it up to you to read those parts, so we can skip over there. And let's also skip over the business rules, since that is not the focus of our presentation today. And next, here we have the system entities and key relationships, being the customer, salesperson, branch manager, vehicle, sale transaction, commission, financing, inventory, and finally the report. Okay, so moving on. Moving on, we have the ERD, where we put the different dimensions and entities and attributes consolidated into one. We have the customer there, the manager, and all the entities and dimensions that I have mentioned before. Okay, let's go next to the normalization process. First, we started with 1NF with first normal form as directed. And to meet the 1F criteria, all multi-valid attributes and repeating transaction groups are removed. For the second normal form, or 2NF, building from the 1NF, 2NF eliminates partial dependencies, and every key non-attribute must depend entirely on the full primary key. You can see here the tables generated, as you can see there. So for the third normal form is the last form of the data that we need, which is to achieve 3NF, transitive dependencies are removed, non-key attributes must depend only on the primary key. As you can see, the example here is the final normalized 3NF set is customer, salesperson, branch manager, vehicle, sale transaction, commission, financing, inventory, and reports, as shown as the clean data set and the ones we're going to use for data mining and data warehousing.
So for this next part, we're going to be discussing the database creation process through the use of MySQL. So as you can see here in the report, we included the screenshots of the codes in MySQL showing the different parts of the database creation process. So let's go into that in depth now. So here we have the SQL script open. So this first part is the operational database, or OLTP. And this includes 11 tables, all normalized to 3NF. So as you can see, this part here creates the actual database, which is over here. And then these next few code snippets all create the 11 different tables that we will be using to store the different data values of the dataset. This part two is the alteration scripts, which alters the table attributes or elements and and this basically creates and arranges all the foreign key relationships with each entity. So yeah. And here is the initial seeding for lookup normalization. So this seeds initial data values into the tables or into the different tables so that data loading later becomes much easier and much more streamlined and it doesn't cause the SQL parser to crash. And lastly, here's the code that loads the different data sets into the tables. Essentially, it creates a temporary raw table to further facilitate data loading, or it also acts as a landing zone for the different data sets. And this table is also deleted upon completion of the data loading process. So yeah. And part two is the data warehouse environment or the OLAP sanctuary. And this includes this is in line with our star schema architecture with comprehensive surrogate keying. So again, this part creates the actual database. So this one right here, deal wheel DW, that means data warehouse. And here are the tables that we will be using for this particular database. So these are the codes that create the said tables over here. And we also needed to include a temporary foreign key check to disabler so that the data sets can be loaded into the tables cleanly and without any errors. And as you can see right here, this is the script that loads the different data sets into the tables. And here we do turn the foreign key check back on so that the program can continue running normally. We only turned it off in the first place so that the data sets can be loaded in without any trouble and without any issues since the foreign keys were already um, fixed or set up earlier on. And here we basically have code snippets which double check and validate the tables that all data was cleanly loaded and that there were no missing values, any incorrect input, any incorrect loads, etc., etc. So yeah. So that's the end of the database setup. And right now we will go into the data warehouse and data mining section. And also to verify there were over 15,000 records loaded into the total data sets since we did use multiple versions of the tables, mainly raw and denormalized tables. So yeah. And now here we have our 20 management questions, which we use to help formulate our queries later on. So here they are. There are 20 of them, so I'll not be enumerating each one, but you can go over each one here and document in further detail. So yeah. And next here we have the different 15 advanced queries for the SQL analytical records. And let's go back here. And we did make separate files for the different queries, but they are also included in the primary SQL file that we are going to submit. So let's just use this one instead. So here we have query one, which is a gross revenue and unit metrics by branch. So this evaluates the baseline revenue performance of all operational branch outlets. The second query is the National Salesperson Commission Leaderboard, where it ranks the entire enterprise sales force based on accumulated commission payouts. Query 3 isolates seasonal variation by rolling up sales metrics by year and month name. The fourth query isolates premier branches generating more than 50 million in gross revenue. 5 basically gauges sales negotiation effectiveness by measuring actual price deviations from MSRP. The sixth one analyzes total capital financed and approved across external banking vendors. The seventh query is the VIP customer lifetime value tiering. So this isolates the highest spending buyers across the entire enterprise. Eight is the intra-branch sales rankings, which evaluates staff rankings isolated strictly within their respective branch teams. Ninth query is a group macro level corporate performance index that indexes them into distinct calendar business quarters. The 10th query pinpoints consumer preference velocity across explicitly tracked vehicle models. The 11th query is a dealership volume spread by day of the week. So this maps foot traffic conversion trends based on the day of the week. The 12th query quantifies cash fluid reserves against third-party unwritten debt pipelines. The 13th query isolates physical locations that fall completely below the national average branch sales baseline. The 14th query measures commission expense burdens relative to sales volume per employee organizational tier. And the last query is a comprehensive star schema executive ledger view, and it completes end-to-end audit representation, connecting all dimensions to a core factual event flow. And to prove that this does work, we're going to be selecting this database right here. And we are going to run one as an example. And here you go. Okay. So that's it for the 15 advanced queries. Again, with the document and the SQL script, you can go over them more in detail. And the next section is the key performance indicators. So I will now stop sharing.
Okay, so for our key performance indicators, so this may screen visible right there. So as you can see, we connected the different CSV files into a one Faxel CSV in order to link all the files and CSV into a one unified branch, as you can see here with the different datas. So first, we start by top branch by gross revenue. We decided to do this, as you can see if I do that, but yeah, you will see the purpose later. But yeah, as you can see, for top branch by gross revenue, we got the San Fernando branch, 849 million pesos. And here's the different regional revenue contribution. As you can see here, by region, everything is sorted, all 5,000 records. So here's the next acquisition volume by quarter. It measures what quarter gets the most sales in a year. So you can see quarter one has the most sales. And next, we got the total discount leak. The total discount leak are the discounts that we get, and I won't say the losses, but it's the discounts we give out every year. So you can see here, we got 591 million pesos. And next, we have the slowest branches by velocity. We have 100. We have Deal Rojas City branch, which only has 189 sales key compared to the Pampanga branch that has more than the Rojas City. So here we have the sales performance champions. For sales performance, we have Angel Bautista with 83 sales key and 159 million pesos in sale price. And in seniority commission overhead, we have sales consultant, senior sales consultant, and floor manager, and last branch manager. Yeah, so you can see there with the text, the sales consultant gets the most commission. And here we have the branch talent yield. Here we decided to use a reference line, more like a average here. As you can see, the majority of the majority of the population of our employees reach more than the average line, and we only have average, which is 7.5 million, with Princess de la Cruz having 26.4 million as the highest. And here we have the core product pillars. You can see here the different products models that we have, and being Nissan Navara being the highest, with the count of sales key being 1,046. And next we have the vintage demand drivers. Many users, not I won't say not many, I won't say many users like older models, but let's just say 2024 has the most vintage users, since we're already living in 2026. For high ticket turn velocity, we can see here which product has the most and which has the most ticket turn velocity, which is the Navara with an MSRP price of 2 million, and with a count of sales key. We can also incorporate that here. So next we have the margin protection anchors, which we can see the different prices and different anchors of the cars. Yeah, the average unit price delta with Fortuner being the highest. So here we have peak transaction seasonality, and yeah, so you can see here what month do we have the most sales key. You can see as seen in the first quarter earlier, it can coexist with that, with January being the highest, where it peaks with 2,066 sales and dips into almost 1,000 only key sales in the month of April. So next we have the liquidity settlement mix and market share with approval status of cash deal being 25.83%. And next is pending status with 36.67%. And let's say the biggest one is the 37.50% approval rate of the market share. So here on other text box, we have the captive finance ticket size. Yeah. And now here, we can see the client wealth and fleet densities where we have the different branches and their different sale prices, with Iligan City being the highest among all of them with the 610.3 million. And next, we have the Alpha Performance Index, which is the best performers of our company and branches based on sales key. And you can see it's Angel Bautista again with the sales key being 83. And yeah, that is all for the KPI right now. Now moving on. OLTP limitations.
Okay, so next part is the evaluation of our operational database or the OLTP limitations. So the first one is a bottleneck of too many joins. So to maintain transaction integrity, operational records are divided across 10 tables. A high-level report such as tracking commissions by vehicle type across region hubs requires computing multiple nested inner join operations simultaneously, which exhausts system resources. Next is a slow report generation and interruption. OLTP systems use row-level locking to handle real-time write operation. So running heavy analytical data sweeps during peak showroom hours can lock active tables, and this can cause software timeouts and freeze our front-end systems. Next is a difficult historical and trend analysis. So operational structures store only the current state of resources. When an asset state changes, old values are overwritten. So this lack of historical tracking makes it difficult to model seasonal trends or calculate salesperson growth histories over multiple years without using complex and slow historical logs. So next part is our data warehouse planning process. So we mainly have four. So first part, we have the select the business process, which is a passenger vehicle retail transaction, sales operations, and workforce commission distribution. Our grain is one individual line item row represents a final vehicle sale transaction at a specific branch managed by an assigned salesperson for a verified customer. The measures are the sales price, quantity, commission rate, and commission amount. And the dimensions are customer, salesperson, vehicle, branch, financing, and the date. And here we have our star schema design. You can look into this more in depth into the document later. So this dimensional model converts natural corporate business keys into clear interbase surrogate keys, branch key, and customer key, etc. to maximize joint performance. And here we have our extract, transform, and load process. So here, for the extract part, raw data entries are pulled from flat files and staging tables without creating read locks on active showroom databases. Transform includes data cleaning, standardized missing credit fields, empty cache strings, etc., etc. So we can read on to this later. And lastly, we have the load, which process dimensions and facts are bulk loaded into the tables using optimized database storage commands, as we discussed earlier in the SQL database setup. And nextly, we have the 15 strategic OLAP queries. So we go back to SQL. This is that part. So these are going to be the OLAP queries. So first one, we have a time dimensional rollup. The next query is a product dimension rollup. Next one is geographical rollup. So these three are basically rollup operations. So if we run one, we can see the annual gross revenue per year and the annual volume. Nextly, we have the drill down operation. So we have dimension, product detail, financing infrastructure drill down. So if we run one of these to show you, here we are. It shows the approved, the status, the finance provider, the volume underwritten, and the capital that was deployed. Nextly, we have slice operations. So we have slicing by time dimension, slicing by product dimension, slicing by financing dimension. So if we run this, here we are, shows the branch name, the name of the salesperson, and the sale price. Okay, and next we have dice operations. So we have multi-dimension dicing, human resource and credit dicing, VIP client, and VIP client inventory dicing. So let's just show off the human resource one. And here you go. And the last one are pivot operations. So one, we have a pivoting fiscal quarter performance across years. The next one is pivoting core vehicles that make across top tier showroom branches. And lastly, pivoting employee commission burdens across fiscal quarters. So let's show off the one for the core vehicles. And here we go. We have the vehicle make, the Manila sales count, Cebu sales count, and Davao sales count. So yeah. Okay, and that's it for our sample OLAP queries. Next, we have the KPI dashboards. So I will leave this to Benj to discuss.
Here, now we have the executive deal a wheel executive summary dashboard with, well, we made two dashboards. Well, here. Now, first we have the high ticket turn velocity, client wealth and fleet densities, margin protection anchors, liquidity settlement mix and market share, captive finance ticket size, and total discount link here, and the peak transaction seasonality. As you saw earlier, here we have it. And next, for the testing, we can test the filter. Yeah, so you can see no records, and yeah, you can see we have a global unified interactive filter that records all and every unified data that is in this data source. Here, next we have the deal wheel executive dashboard, part two. Here we have the sales performance champions, Saw, Angel Bautista, and the branch talent yield with the reference line and average, the core product pillars with the Nissan Navara, with the acquisition volume by quarter, which is, yeah, quarter one being the highest, and the vintage demand drivers being 24 is the peak. And the different X boxes shown here in San Fernando, Angel Bautista, and Bill Avil Rojas City. And now to test the filters, the Almera, the PRV, the Civic, CRV, yeah, and Singular, and then let's put them all back. And that is all for the dashboard. And moving on, we have mix for the last part of our presentation.
Okay, so lastly, we have the data mining analysis suite. So for these methodologies, we mainly chose two. The first one is the Market Basket Association rule mining. So our objective was to identify cross-selling patterns by analyzing which vehicle options, financing bundles, and after-sales service packages are most frequently purchased together. So the input variables are going to be the vehicle key, the financing key, the branch key, and customer key profiles. And the method used was the a priori algorithmic sequence, which was applied to all transaction invoices to calculate support, confidence, and lift thresholds. And the results analysis revealed a strong rule association. Customers purchasing mid-tier SUVs, mainly um, the Toyota Fortuner, show a 78% confidence score to secure financing via explicit providers, mainly BDO Auto Loan, when deals are closed during Q2 seasonal intervals. So our insight from this was financing decisions are heavily influenced by vehicle choice and regional promotional periods. And we recommend a when we and our recommendation is to pre-approve specific bank credit packages during early vehicle consultations to shorten sales floor cycle times. For our second one, it is a time series demand forecasting. So our objective is to project monthly warehouse inventory demands by make and model category across the next 12 calendar months. So the input variables are going to be a historical transaction stamps. So these are where the date keys come in, sales price records, and vehicle counts aggregated over a 36-month baseline. So the method used was an autoaggressive integrated moving average. Predictive model was applied to chronological transaction data. So for our result, the predictive model forecasts a 14.5% surge in compact sedan volume, mainly a Honda Civic, during Q3 and Q4 intervals, while highlighting a plateau for premium high MSRP vehicles. So our insights from this are that customers demand shifts predictably based on seasonal hiring trends and annual corporate bonus structures. And we recommend to adjust inventory levels by moving compact models to high demand hubs ahead of peak seasons to prevent stock shortages or excessive carrying costs. And that's it for our project presentation. Again, some of the other details can be viewed in the project document and SQL files that we will be including, as well as the Tableau dashboards and KPIs as well. So that was it. Thank you and have a good day.
Thank you.